Alright, just while you're on your way over, let's see if I can help just sort out the last few of these. Here I've got sine x equals a half, so halfway to 1, that'll be about here. And I'm in the second quadrant between pi over 2 and pi. Remember, pi is all the way over here, that's 0. Pi over 2 must be halfway. So in the second quadrant, I'm over here. That's the angle that I've got there. Find cosine theta and hence find tan of x. Right, well, 1/2, that's one of our exact value trig numbers we should remember. So draw our little best friend's little buddy that goes with our unit circle, who is of course our best friend in maths. Small angle, pi over 6, opposite the small side. Larger angle, 1/3 of pi, opposite the larger side. So if I want sine to be 1/2, then I want the 1 to be the opposite side and the 2 to be the hypotenuse. So the angle we're talking about must be pi over 6 away from the x-axis. All they want me to do is find cosine x. Well, cosine x is going to be pretty easy to find, isn't it? Cosine of pi over 6 is √3 over 2, but we need to remember what quadrant we're in. Only sine is positive here, or cosine's my x-coordinate, so cosine's negative in this quadrant, so it's just going to be negative, and we know the ratio is going to be adjacent over hypotenuse, √3 over 2. And that's all you've got to do. Draw the triangle, show that cosine equals √3 over 2, and you're pretty much done. Tan of x, well, I can do sine theta, 1/2 divided by cosine theta, but you can also just say, well, in this quadrant, tan is negative, so it's going to be negative whatever the tan of pi over 6 is. And the tan of pi over 6 is 1 over √3, so you can leave it as negative 1 on √3. It's more polite in maths to not have a surd on the bottom, so we can rationalise that denominator, multiplied by √3 over √3, and we can get negative √3 on 3. I'm not sure if your teachers will be quite as fussy as I am about that, but it's the right answer either way. So that's all we have to do. Let's try another one. Let's try B here. Cosine x equals negative 1 on √2. So I'm just going to try and carefully rub out just the angle. That's pretty good at erasing. Oh, I spoke too soon. That'll do. Let's just rub out those ones. Why is it every time I do that one, it doesn't work? I don't know. Let's just scribble that out and let's keep going. Alright, cosine of x equals negative 1 on √2, and I'm between pi and 3 pi on 2, so I'm in the third quadrant. Negative 1 on √2, let's just pretend it's that one that's already marked there, why not? So that cosine's the x-coordinate, negative 1 on √2. Well, 1 on √2, that comes from our other best friend little buddy. It doesn't look like a right angle, but I labelled it 1, so it is. This one, of course, is the isosceles one where we've got pi over 4 and pi over 4. All good there. And we want to find sine x and tan x. Well, in this quadrant, in the third quadrant, sine of x is going to be negative, because we go only tangent's positive here, so sine of x is negative, and if we do opposite over hypotenuse, it's also going to be 1 on √2. And I would love you to simplify that to negative 2 on √2, but given that your book writes it that way, I'm sure no one's going to mind too much if you leave it the first way. They're both correct. Remember, how did I do that? Just multiply by √2 over 2 on √2 on √2, and I wrote that one upside down. Let's try that again. Negative √2 over 2. Multiply top and bottom by √2. 1 times √2 is √2. √2 by √2 is 2. Mouthful. All right, tan of x. Tan of x, well, this is the 45-degree one, so we can see it's already going to be 1, and tan is positive in this quadrant, but let's just check. Opposite over adjacent, yep, that's 1 as well, so the tan of x equals 1. If I go on to part C, sine of x equals negative √3 on 2. Let's redraw the unit circle because that's getting a bit messy. See if we can fix up the next one. that's a nicer circle anyway, I think. Sine of x negative root 3 over 2, so it's going to be down here, pretty close to negative 1. And we're between 3 pi on 2 and 2 pi, so we're over here in the fourth quadrant. So now I know my cosine is going to be positive, my tan and sine are both going to be negative. Okay, root 3 over 2, if we go back to this triangle, if I want root 3 to be the opposite side, I must be dealing with a pi over 3 angle. So I use that angle to work out cosine and sine. Cosine and tan, we've already got sine. So the cosine of x for that one, so the cosine of x is going to be the x coordinate there. It's going to be positive, isn't it? We know it's positive from the ASTC. We know it's positive just by looking at the x coordinate. If we're dealing with pi over 3, cosine is adjacent divided by hypotenuse. It's going to be a half. What about the tan of x? Tan of x is the opposite divided by the adjacent. So it's going to be root 3, but in the fourth quadrant, we're going to be negative. So it's negative root 3. Lucky last, part D. Tan of x equals root 3, and I'm between pi and 3 pi over 2. So root 3 is just going to be going up and hitting the tangent axis somewhere up here at root 3. There's my tangent axis, there it is, beautifully drawn, all in the right place. If tan equals root 3, it's opposite over adjacent. I must be dealing with a pi over 3 angle again. Now, in the third quadrant, both sine and cosine are negative, aren't they? Tan's the only thing that's positive. So I'm just going to use this pi over 3 angle. The sine of pi over 3 is root 3 over 2, but it's going to be negative, so sine x. In the third quadrant, it's negative. The size of it is root 3 over 2. Cosine x in the third quadrant is also negative, and the cosine of pi over 3 is 1 over 2. So that's negative 1 over 2. That's how we do the last one. You can always watch that again in the morning, and maybe it'll give you just a little bit of confidence. I think I don't know what that recorded then, if it recorded my face or not. Maybe it's better off without it. Who knows? All right. Good luck, Lou. Stay calm. You'll be all right, champ. Bye.